Good afternoon, this is Mr. Gonzalez here. I hope everybody's doing okay. We are going to do our third lesson online today. We did completing the square on Monday, quadratic formula today, and for tomorrow we're supposed to be doing discriminant. So as always, I start you guys off with a do now, and this is what I'm asking you to do. Solve each quadratic equation using the quadratic formula, which is right here. State rational roots in simplest radical form and round irrational roots to the nearest thousands. Okay, it all depends on what kind of roots we're gonna get as we solve the problem. Okay, I'm always like problem number one. I mean A, B, C. A, I always list like the variables so you can identify the values. So I know that A here is 1, B is -2, and C is -8. All these numbers come from here, A, B, and C. Now, quadratic formula is right here, so what you have to do is substitute every number. Remember, like I said before, okay? In the equation, the negative sign, you cannot forget about this sign because this is part of the equation, okay? Now, because B here is -2, so I always suggest you to write it in parentheses, okay? So -2 plus minus the radical, and again, B, because it's negative, you have to put it in parentheses, minus 4 times 1 times -8. Now, everything divided by 2 times 1. And I believe you can go from there. Minus the minus give you plus, plus minus, and when you find under the radical, -2 squared is 4, -4 times 1 times -8 give you +32. Everything divided by 2. Continue solving. X equals 2 plus minus radical 36. If you notice it, that is a perfect square. So the square root of 36 is 6. So you write your answer. X equals 2 plus minus 6, okay? Plus minus 6. Everything divided by 2, then you can just split your roots, and your first root should be x equals 2 plus 6 equals divided by 2. That will give you 4. And 2 minus 6 divided by 2, that will give you -2. So those are your roots. And because they're real roots, okay, the whole number, so this is what we're going to learn today. The discriminant. The discriminant is the value, okay, when you calculate everything that is under the radical. So this part over here that we're going to do on the bottom, only that will give you the value of the discriminant. Now, because the discriminant is 36, all right? And it's a perfect square, you can see here. Okay, 36, sorry, I don't know if you can see it. Let me just move this a little more. 36 is a perfect square. Then you have two rational unequal roots, okay? Because you have a -6 and +6. I mean, you will have two, you can see you have two different roots, one positive and one negative. So that's what is called two rational unequal roots. And that means that the x-intercept should be 2 because that means that it will touch the x-axis twice, 2 times, okay? So because of the x-intercepts are 2 because there's two roots, that means that the graph goes through +4 and -2. So that's what we're going to do today. Now, letter B, we do the same thing. A is 1, B is 6, and C is 6. This is what I meant. Look, in this case, because this negative, okay, is from the formula. Now, because the 6 is positive, I don't have to put in parentheses. Neither here, okay, neither inside the radical. But if you put in parentheses, it will make any difference. So 6 squared minus 4 times 1, which is A, times 6, which is C. Once I evaluate that, okay, of course, everything divided by 2 times A, which is 1. When you evaluate all that, okay, you will come out with -6 plus minus radical 2. If you notice, radical 2 is not a perfect square. So you're not going to have real numbers. You're going to have irrational numbers. So they're asking me here if I have irrational numbers to write it in simple radical form and also as a decimal. So we're going to do it both ways. So that means that we have to simplify radical 12. And radical 12, okay, the larger perfect square, the radical 12 is 4. okay, times 3. So radical 12 becomes 2 radical 3. So that means, guys, that this radical 12 becomes 2 radical 3 that I got it from there. So I write my answer like that. X equals negative 6 plus 2 radical 3 divided by 2. All right? Now remember, we can simplify this, okay, because they all divisible by 2. So if I divide negative 6 by 2, I get negative 3 plus minus 2 divided by 2, that becomes 1. So I don't have to write it down, and that's radical 3. So my radical form should be x equals negative 3 plus minus radical 3. But because they also ask us to divide it as a decimal to the nearest thousand, so what I'm going to do, I'm going to split them and I'm just going to put it in the calculator. If you can see, what I did here is I separate them. Negative 3 plus radical 3, negative 3 minus radical 3, and I just put it in the calculator. So they're both going to be negative 1.268 will be this one, and this will be negative 4.372. So I have my answer in two different forms, simple radical form and as a decimal, okay? Now, let's continue. Oh, okay, now, the discriminant here, remember, is the value under the radical. So the discriminant here is going to be 12. And because it's not a perfect square, right? It's not a perfect square. I don't know if you can see that, probably will, okay? Then you have two irrational unequal roots, okay? Two irrational unequal roots, because that's one root, that's the other root, okay? And obviously it will touch the x-axis twice. So intersect the x-axis twice. That's B. Now C, okay, problem number C, we have the same thing, okay? I don't gonna spend much time on this one because you know how to solve. What I did is I just identify my values, okay, of A, B, and C, and just plugged in. Once I plugged in, remember, because the B here is positive, I don't put it in parentheses. But if you do, it will not affect your answer, right? So once I simplify, that's what I get, okay? So that means that once I solve the whole thing, my answer becomes, under the radical becomes 0. Remember, that's going to be my discriminant, okay? So discriminant is going to be 0. And when I solve, look what happened. I only have one root because, you know, plus minus 0 is not going to change the answer. So you will have x equals negative 4 over 2. So x equals negative 2. From here, I went to there. That means that it's a double root. Therefore, the discriminant is 0. Okay, the nature of the root is one real solution because only one number, but it's also remember two equals, because that's like saying negative 2 twice, and it only touch the one intersect once. Okay, now we're gonna give you in more detail what the discriminant is. Okay, so the discriminant is the radicand b squared minus 4ac. The value under the radical sign in the quadratic formula. It is the square of the value following the plus minus sign. So you have four choices. If the discriminant is greater than 0, okay, I mean it's going to be positive in perfect square, then you have two rational solutions, okay? They're going to be also unequal. If it's greater than 0 and positive non-perfect square, you're going to have two rational solutions, also unequal. If it's equal to 0, okay, if the discriminant is equal to 0, the equation has one real solution. That means double root. And if it's less than 0, the equation has two imaginary solutions. That means negative. All right, so now let's go on the back and do a couple examples. Let me turn the page. Ta-da! Okay. Here's my first problem, okay? For each quadratic equation, find the discriminant, describe the nature of the root, and describe the x-intercept. So when you're gonna look for the discriminant, you have to concentrate on this formula only, okay? So you still need to find your values of A, B, and C. So in this case, A is A, B is negative 13, and C is 3. So I'm just going to use the inside part of the radical, okay, to find the discriminant. So it will be negative 13 squared. See, I put it in parentheses because that's negative. Minus 4 times 8 times 3. Once I solve, I get 144. Actually, it's going to be 13 should be 169. 1 second. So that will be 169. I put 144, but it's 169 minus 96. And that will give you, I don't know if it give you 73, but let's see, because I didn't realize that I'm making mistakes. Minus 96, so 906 is 3. Okay, so discriminant, so I did, the answer is correct. I just put it the wrong number. So it's 73, so discriminant here is 73. It's a positive non-perfect square, so you have two irrational unequal roots, okay? And 2 times that intersect the x-axis, all right? Now with the other one, the same thing, okay? A is 6, B is 1, and C is 12. So once I plugged in 1 squared, I put in parentheses because it's positive, minus 4 times 6 times 12, and I get 1 minus 288, which gives me negative 287. The discriminant here is negative 287. You know, it's negative, so the root's going to be imaginary. 2 imaginary roots, non-real, okay? Because the discriminant is negative. You cannot have negative roots, all right? And never touch the x-axis, okay? It never does. So the x-intercept never intersect the x-axis. Now we have 2 more, okay? So let me just fold the page again. This is going to be I'm going to do the lessons, guys, so you have to bear with me. Okay, the other one, if you notice here, I have 3 as an A, I don't have B, and I have C as negative 12. So because B is 0, that becomes 0 squared minus 4 times 3 times negative 12. Once I solve that, that gives me 0 plus 144. So the discriminant here is 144. So the discriminant is 144, which are 2 rational unequal roots, okay? So this goes here. That's my answer for there, guys. I'm sorry, I put it right there. And it's a positive perfect square. So you have 2 rational unequal roots. Now, it touches the x-axis twice, so the x-intercept is 2. With the other one, same thing. I plug in, okay? A is 1, B is negative 6, and C is 9. Because that's negative, remember, guys, I put it in parentheses, okay? And once I solve that, what happened? The discriminant becomes 0 because negative 6 squared is 36, and negative 4 times 9 is 36. So that means it's a double root. That's one real solution, okay? On equal roots, that means that we have 2 equal roots. And it touches the x-axis just once, all right? And my last question that I asked is just to match, okay? We have 3 equations and we have 3 graphs. To match the discriminant with its corresponding graph. So if you take a look at this graph right here, it only touches the x-axis once, okay? So intersect x-axis once. So discriminant has to be equal to 0, okay? Sorry about the mess. So that means that it has to be choice B because this one, discriminant, is equal to 0. So that becomes part B. If you notice this, guys, this graph never touches the x-axis, okay? It doesn't touch the x-axis. Therefore, discriminant is less than 0 or negative. Okay, so that means that discriminant is not equal to 0, so that's negative, so that means they have to be less than 0, right? So that's going to be choice C. Therefore, this one, because it's greater than 0 and it touches twice, that has to be letter A, okay? Intersect x-axis twice. All right? So I hope you guys understand the lesson. Otherwise, you can go to Apex and remember, pick the first unit I think that I selected over there, and you can go through the whole lesson, all right? And will be more examples there. I think I'm not gonna post another lesson until Monday, so I guess for tomorrow, for Thursday and Friday, you can keep practicing, okay, on the Apex. And please don't forget to submit your homework, even if you late, it doesn't matter. You have the whole week to send it to me, because we know we're waiting for you guys to set up your accounts, okay? Stay healthy and have a good day. Bye.